In this video, we are going to be showing that if we are given A and B as real numbers, if A0 is less than A, which is less than B, then A squared is less than B squared. That is the first part which we want to prove, this part. Then after that, if A squared is less than B squared, is it necessarily true that A is less than B? Give an example to illustrate your answer. So the first part, say, suppose that uh, 0 is less than A, which is less than B. For AB, which are real numbers. What does this mean? This means that we have two real numbers, A and B, which are greater than 0, which is positive real numbers. So we need to show that A squared is less than B squared. This one is a simple one. So the first thing we have to do is we just have to multiply on this one. So if we multiply on this one by A, we get A by 0 is less than A squared, which is less than AB, multiplied by A. That is the first part. Then the second part we multiply by B. So multiply by B on the second part. So we get B by 0 is less than BA, which is less than B squared. We are just multiplying this by A and by B. So you can actually see this actually formed something new. We have, for the first one, we have 0 is less than A squared, which is less than AB. And for the other one, we have 0 is less than BA, which is less than AB. So since for real numbers, for AB element of real numbers, AB is equal to BA. We have, we know this is a commutative law. So we have A squared being less than AB being less than B squared. This is by transitivity. And you can actually see as a result that this implies that A squared is less than B squared. As a result, this is what we wanted to prove. Okay, so for the second part, we are going to prove or disprove the following. Is it true that if A squared plus B squared is, if A squared is less than B squared, then A is less than B? So I'm just going to prove this one by using a counter example. So what is a counter example, you might wonder? A counter example is that example which disproves a statement. If you just put that number in the statement, it will disprove it. So sometimes if you want to prove that something doesn't hold, you can just choose one example which it won't hold, right? So for example, in this case, if we consider, suppose that A is equal to, let's say, -1, and B is equal to -2. So A squared is equal to minus 1 squared, which is less than minus 2 squared, which is equal to 4, which is equal to b squared. So just took, well, let me write it in this way. B squared. So this is actually resulting in 1 is less than 4. But minus 1 is actually greater than minus 2. So this is a contradiction. So this implies that a squared less than b squared does not imply a is less than b. There are some cases where it holds, but it doesn't always imply that a is less than b. You can choose some examples. I know some people make this mistake of choosing some examples which it will hold. Like if you choose any positive numbers, let's say we choose 3 and 4. 3 and 4. 3 and 4 means that a squared is 3 squared, which is 9, and b squared is 4 squared, which is equal to 16. And you can actually see here a squared is less than b squared, is implying that a is less than b. But if they are negative numbers, it doesn't imply that. So this means that this one is not true. It's not always true. Thank you for watching.